Okay, this is problem number 24, and it reads, since 2000, when 100,000 cases were reported, each year the number of new cases of equine flu has decreased by 20%. Let P sub n denote the number of new cases of equine flu in the year 2000 plus n. And then it asks for three things. A, give a recursive description of P sub n. Give an explicit description of P sub n. And then if the trend continues, approximately how many new cases of equine flu will be reported in the year 2015? Okay, so let's start with A. A recursive description of P sub n is always that P sub n is equal to P of n minus 1 times R. For a geometric series, and this is a geometric series because each year the number of new cases will decrease by a certain percentage, 20%. That means that you have to multiply the number of cases in one year by 0.8 in order to get the ones for the next year. So this will be true with R equals 0.8, only because that represents 20% decrease, and that's really what this problem is about. Then it says, give an explicit description of P sub n. Well, the explicit description of P sub n is equal to P0 R to the n. And you can see that that gives you the right formula if n is equal to 0, because R to the 0 is equal to 1, and you just get P0 equals P0. That's just a way of checking. Make sure you've got the right n in there. Now, in this case, we know that R is 0.8, so you could also say that this is equal to P0, 0.8 to the nth power. That's also in the explicit description. Okay, now, if the trend continues, approximately how many new cases of equine flu will be reported in the year 2015? Well, to get that, we need to put n equals 15. Because P0 is the number in year 2000. Now, another thing we should say here is that P0 is 100,000. That's how many. I didn't say that before. 100,000. And you could put that in here on the explicit formula if you wanted to make that. I shouldn't really put it like that. I should put it right where it belongs, but it's trouble to cram it in. So 100,000 times 0.8 to the n. That's the explicit formula. Now, in order to do part C, let me just erase this to give a little space. We erased A and B. We already answered A and B. It says, now here all we really want is P to the 15. That's going to be equal to 100,000 times 0.8, in this case, to the 15th power. And once again, I'm going to use my calculator for this. That's what it's for. I'm going to put in 0.8 x to the y, 15 equals, and that's 0.035. We get 100,000, which was the initial number, times 0.035. And it's got more decimal places, but that's enough for me. That's 3.5%, basically. And we can multiply that by the 100,000, or we can just use common sense. 100,000, 1% of 100,000 is 1,000. 3% is 3,000, and 3.5% is 3,500. So this would be 3,500, roughly. If I look at my calculator, I see that it would actually be, since this was 0.35 3.18. I could actually say that it's 3,518, approximately, rounded off to the nearest person who's got equine flu. So anyway, I think that's it for problem 24.